On this Ram 2500 with the 6.4HEMIGas engine, P0302 means the PCM has identified a cylinder 2 misfire pattern. The truck may idle rough, hesitate, lose power under load, or the MIL may flash if the misfire is severe. Broadly, this can come from air, fuel, ignition, mechanical compression, valvetrain or VVL behavior, wiring, or in the last part of the diagnostic path, PCM control. Start with the basic system checks, then work the fault in order instead of jumping straight to parts. The misfire monitor runs only when its enable gates are met: fuel level above 12%, battery voltage above 9 volts, ambient temperature above -23 degrees C, -9, 4 degrees F, coolant temperature at engine start above -7 degrees C, 19, 4 degrees F, or if the start temperature is below the threshold, when engine temperature reaches 21 degrees C, 69, 8 degrees F. The engine speed gate is between approximately 400 RPM and 6,200 RPM, and the monitor is disabled during a DFSO event. The PCM sets the code when crankshaft speed variation between cylinders exceeds its calibrated limit for the current speed and load. First, turn the ignition on, pull and record all codes and captured operating data. Then operate the vehicle under the same captured conditions from when P0302 set. During the drive, pay attention to when the misfire shows up, because that operating condition matters later. Watch the downstream O2 sensor behavior while the misfire is happening, and use the misfire monitor to confirm whether cylinder 2 is showing excessive misfires right now. If it is not active, treat it as an intermittent condition. If other codes are present for fuel, ignition, air handling, VVT, or VVL systems, check what they mean first before continuing this cylinder-specific path. A low-side downstream O2 pattern during the misfire points you toward a lean or fuel delivery problem, while a high-side pattern points toward excess fuel in the catalyst from lack of spark or a possible leaking injector. Also remember that during a severe misfire, the PCM can shut off injector control for the affected cylinder to protect the catalyst, and that can make a high-load misfire seem like it is still there when the engine comes back to idle. Next, make a broad inspection before narrowing it down. Look for belt or accessory issues that can disturb crankshaft speed, sensor mounting problems at the crank, cam, or MAP sensors, poor connections at the key engine controls, PCM power or ground corrosion, vacuum leaks, intake or exhaust restrictions, internal engine concerns, moisture on ignition parts, low or poor fuel, or load-related conditions like bogging or overload. If you find a problem here, repair it and move to repair verification. If not, check the engine and intake manifold for vacuum leaks. A leak can affect one cylinder or more depending on where it is. Then check fuel quality: water in the fuel, wrong fuel type, old or contaminated fuel, low fuel and proper ethanol level. If the fuel is the problem, replace the fuel and if needed, flush and clean the fuel system, then verify the repair. If the basic checks pass, test for a clogged or leaking injector. Safely relieve fuel pressure before opening the system, because the fuel system can stay under constant pressure even with the engine off. Install fuel pressure decay tester 8978A at the fuel rail. Turn the ignition on, let pressure reach maximum and stabilize, and record that as the starting pressure. Actuate the cylinder 2 injector with the scan tool while watching the gauge, then record the ending pressure. Repeat the same process on several known good cylinders, always starting the injector actuation from the same starting pressure. The ignition may need to be cycled off and on a couple of times to reach maximum rail pressure. After each injector actuation, start the engine to clear fuel from the cylinder to avoid engine damage. If cylinder 2 ends about the same as the others, keep going. If cylinder 2 stands out, a small pressure drop points toward debris in the rail or injector, and a large pressure drop points toward a faulty or fouled injector. Repair what you find and verify the repair. Next, move to ignition and cylinder condition. Turn the ignition off, remove the fuel pressure decay tester and reconnect the fuel lines before continuing. Remove the ignition coil from cylinder 2, reconnect the coil connector, unplug that cylinder's fuel injector connector, install a spark tester on the coil and crank the engine. If there is a crisp blue spark, continue. If not, skip ahead to the coil power and control circuit tests. With spark present, turn the ignition off and inspect the spark plug and cylinder. Look for cracks, carbon tracking, oil, coolant, or excess fuel fouling, a gap out of specification, or a loose or broken electrode. Also check for signs of oil or coolant in the cylinder. If any of those conditions are found, replace the spark plug, and if oil or coolant is present, diagnose and repair that cause before verifying. If the plug and cylinder look acceptable, perform a compression test on all cylinders and compare cylinder 2 to known good cylinders. If compression is not within specification, use a leak-down test to decide whether the issue is in the valvetrain or combustion chamber, repair as needed and verify. If compression is within specification, swap the cylinder 2 spark plug with a known good cylinder, or replace it if access makes swapping impractical. Then run the engine and watch the misfire monitor. If the misfire follows the plug, replace that plug. If replacing the plug makes the misfire go away, the repair is complete and still needs verification. If it does not follow and does not go away, continue. If the plug swap does not identify it, decarbon the valvetrain and combustion chambers using MOPR combustion cleaner. After driving and clearing the cleaner from the engine, erase the codes, drive the truck under the captured conditions, and watch the misfire monitor. If the misfire does not return, the carbon cleaning repaired the fault. If it does return, check engine oil level and condition before going deeper. Look for mechanical tolerances out of specification, oil pressure out of specification, low oil level, an incorrect oil filter, dirty or deteriorated oil, contaminated oil, incorrect viscosity, or aerated oil. Skipping these checks can lead you the wrong way. If any are found, repair the oiling or mechanical condition and verify. If not, consider VVL operation only if the misfire occurred when engine speed exceeded 5,000 RPM and VVL still makes sense as a suspect. One VVL pattern can cause a misfire at or above approximately 5,000 RPM without always setting a VVL code, so check solenoid O-rings and leakage before moving into rocker inspection. Be careful here. The cylinder detail in this VVL path does not clearly line up with cylinder 2, so pause, recheck the earlier diagnostic path, and avoid guessing before making a VVL repair decision. After that, visually inspect the camshaft lobes, rocker arms, and springs for excessive wear or broken parts. If wear or broken parts are found, make the appropriate repair and verify. If nothing is found there, move to the harness and control side. If the spark test failed earlier, start the electrical side at the ASD relay output to the ignition coil. Keep clear of the fan, belts, and pulleys anytime the engine is operating. Turn the ignition off, disconnect the ignition coil connector, turn the ignition on, and actuate the ASD relay with the scan tool. Using a 12-volt test light connected to ground, probe the ASD relay output circuit at the ignition coil connector. If the light does not illuminate brightly, stop the scan tool actuation and repair the open or short to ground between the PDC and the coil connector, then verify the repair. If it does illuminate brightly, test the coil control circuit. Use a 12-volt test light connected to a 12-volt source, backprobe the coil control circuit at the ignition coil connector, and crank the engine for 5 seconds. If the light blinks brightly while cranking, replace the ignition coil and verify. If the light stays on constantly, check the coil control circuit for a short to ground. Turn the ignition off, disconnect PCM-C2, install GPEC diagnostic adapter 10436 on the engine harness side, and check continuity between ground and the coil control circuit at the coil connector. Do not probe the PCM harness connectors directly, because that can damage the terminals. If there is continuity to ground, repair the short to ground and verify. If there is no continuity, continue to the harness connection check. If the control light was off constantly during the crank test, measure resistance in the coil control circuit between the ignition coil connector and the GPEC adapter. If resistance is not below 3.0 ohms, repair the open or high resistance and verify. If it is below 3.0 ohms, continue. The last diagnostic step is to go through the related PCM inline and component harness connections. Disconnect the PCM connectors, related inline connectors if equipped, and related component connectors. Inspect connector installation, locks, corrosion, water intrusion, seals, bent terminals, overheated terminals, push-back terminals, spread terminals, and terminal tension. Repair any condition you find. Then reconnect everything and make sure all connectors are fully seated and locked. Erase the codes, operate or road test the truck under the proper conditions, and read the codes again. If P0302 returns after this path, replace and program the PCM, then verify the repair. If the code does not return, the wiring or poor connection problem has been repaired. The key on P0302 is to prove the cylinder 2 misfire under the same conditions first, then separate air, fuel, spark, compression, valvetrain, and control circuit causes in order. Do not let the misfire counter alone sell you apart. For more diagnostic training, visit Diagnostics.com.